Jupiter. Introduction to Jupiter. High above in the night sky, a bright, wandering star has fascinated humanity for thousands of years. This is Jupiter, the king of the planets, the giant of our solar system, with its swirling clouds, mighty storms, and powerful magnetic field. Jupiter is unlike any other world we know. It is so massive that it could hold more than 1,300 Earths inside. Yet it spins so fast that a day lasts less than 10 hours. Jupiter is more than just a planet. It is a cosmic guardian, shaping the destiny of the solar system with its immense gravity. It protects Earth by deflecting comets and asteroids, controls the orbits of countless space rocks, and holds a vast family of moons, some of which may hide oceans where life could exist. From the mysterious Great Red Spot, a storm larger than Earth, to its dazzling auroras at the poles, Jupiter is a world of extremes, beauty, and power. Since ancient times, civilizations have worshipped it as a god, studied its movements to mark the passage of time, and later, through the telescope, discovered moons that changed our view of the universe forever. Today, as spacecraft continue to explore this colossal world, Jupiter remains not only a planet of mystery, but also a key to understanding how our solar system, and perhaps even other planetary systems, came to be. Basic facts about Jupiter. Position in the solar system. Jupiter is the fifth planet from the Sun, orbiting between Mars and Saturn. It lies about 778 million kilometers, 484 million miles from the Sun, which is more than 5 times farther than Earth. Because of this distance, sunlight takes about 43 minutes to reach Jupiter. Its position makes it a dominant force in the middle region of the solar system, influencing nearby asteroids and comets with its powerful gravity. Type of planet. Jupiter is a gas giant, meaning it does not have a solid surface like Earth or Mars. Instead, it is made almost entirely of gases, mainly hydrogen and helium. Gas giants are much larger and heavier than terrestrial planets, and Jupiter is the largest of them all. Its massive size gives it strong gravity, a powerful magnetic field, and extreme weather systems. Diameter. Jupiter's diameter is about 142,984 kilometers, 88,846 miles across the equator. To compare, Earth's diameter is only 12,742 kilometers, 7,918 miles. This means Jupiter is 11 times wider than Earth. If Jupiter were hollow, you could fit more than 1,300 Earths inside it. Mass. Jupiter's mass is 318 times greater than Earth's, making it the most massive planet in the solar system. Despite its size, Jupiter is not very dense. It's mostly made of gas. Its density is only about 1.33 grams per cubic centimeter, a little higher than water. This means if there were a gigantic ocean big enough, Jupiter would actually float. Day length. Jupiter has the shortest day of all planets. It completes one full rotation in just 9 hours and 56 minutes. Because of this rapid spin, the planet bulges at the equator and flattens at the poles. This fast rotation also drives its strong jet streams, causing the colorful bands and storms in its atmosphere. Year length. Year on Jupiter. Its orbit around the Sun takes about 11.86 Earth years. That means while 1 year passes on Jupiter, nearly 12 years pass on Earth. This long orbit is due to its great distance from the Sun. Moons. Jupiter is like a mini solar system on its own. It has at least 95 known moons. 4 of them are especially famous: the Galilean moons, Io, Europa, Ganymede, and Callisto. Discovered by Galileo Galilei in 1610. Io is volcanic and fiery. Europa may hide a liquid water ocean under its ice. Ganymede is the largest moon in the solar system, even bigger than Mercury. Callisto has one of the most heavily cratered surfaces. These moons alone make Jupiter a fascinating system for exploration. Rings. Like Saturn, Jupiter's rings are faint and not easily seen. They are made mostly of dust particles thrown into orbit by meteoroid impacts on its moons. The ring system has three main parts: the halo ring, the main ring, and the gossamer rings. They are very thin and dark, which is why they were only discovered in 1979 by the Voyager 1 spacecraft. Structure and composition of Jupiter. Overall nature of Jupiter. Jupiter is not a rocky planet like Earth or Mars. It is classified as a gas giant, meaning it is mostly made up of gases, with no solid surface to stand on. When you look at images of Jupiter, you are not seeing land, you are seeing the tops of its thick cloud layers. If a spacecraft tried to land, it would sink into the atmosphere and be crushed by pressure long before reaching any kind of core. Atmospheric layers. The atmosphere of Jupiter is one of the most complex in the solar system. It is mainly composed of hydrogen, about 90%, and helium, about 10%. Very similar to the Sun. Traces of other gases like methane, ammonia, sulfur compounds, and water vapor also exist. The atmosphere can be divided into several layers. Troposphere, the lowest visible layer where clouds, storms, and the Great Red Spot exist. This is the layer we mostly see in telescope images. Stratosphere, above the troposphere. This region contains hazes and chemicals created by sunlight breaking down gases. Thermosphere, extremely hot due to solar radiation and Jupiter's strong magnetic field interactions. Exosphere, the outermost part, blending into space. Cloud bands and zones. Jupiter's famous striped appearance is caused by bands of clouds that circle the planet in opposite directions. These are driven by fast winds called jet streams that can reach up to 650 km/h. 400 zones. Light bands, made mostly of ammonia ice crystals. They rise upward and appear brighter. Belts. Dark bands, made of deeper, warmer chemicals like ammonium hydride. They sink downward and look darker. These belts and zones interact, creating massive storms and turbulence across Jupiter's atmosphere. The Great Red Spot in storms. One of Jupiter's most famous features is the Great Red Spot, a gigantic storm larger than Earth. It has been raging for at least 350 years, possibly much longer. The storm rotates counterclockwise and has wind speeds up to 432 km atau 268 mph. Apart from the red spot, Jupiter constantly produces smaller storms, some as large as Earth itself, that appear, merge, or vanish. The planet is a storm factory, with lightning strikes up to 10 times stronger than those on Earth. Deeper layers, pressure, and temperature. As you go deeper into Jupiter's atmosphere, pressure increases enormously, hundreds of thousands of times greater than Earth's surface pressure. Temperature rises from about -145°C, -234°F, at the cloud tops to tens of thousands of degrees near the core, at certain depths. Hydrogen gas gets squeezed so tightly that it changes into a special state, called liquid metallic hydrogen. This exotic material conducts electricity like metal and is responsible for Jupiter's powerful magnetic field. Interior layers. Scientists believe Jupiter's internal structure is made of several layers: outer atmosphere, hydrogen, and helium, gas with clouds of ammonia, water, and other chemicals. Liquid hydrogen layer. As pressure increases, hydrogen turns into a liquid state, forming a vast ocean of liquid hydrogen. Metallic hydrogen layer. Deeper down, pressure becomes so intense that hydrogen atoms lose their electrons, creating a sea of metallic hydrogen. This layer may be thousands of kilometers thick, and is key to Jupiter's magnetism. Core possible. The exact nature of Jupiter's core is still debated. Some models suggest a dense, rocky icy core, about 10 to 20 times Earth's mass, while others suggest the core may be partly dissolved into the metallic hydrogen layer. Composition. Similarity to the Sun. Jupiter's overall composition, mostly hydrogen and helium, is almost the same as the Sun's. This is why scientists call Jupiter a failed star. If it had been about 80 times more massive, nuclear fusion would have ignited in its core. and it would have become a small star instead of a planet. Energy and heat from within, unlike Earth, which gets most of its heat from the sun. Jupiter actually radiates more heat than it receives. This is due to leftover energy from its formation and the slow contraction of the planet. Jupiter glows faintly in infrared, releasing almost twice as much energy as it absorbs from sunlight. Jupiter's structure is a layered giant of gas, liquid and metallic hydrogen, with possibly a small core. Its powerful storms, deep atmosphere, and unique chemistry make it one of the most dynamic and extreme worlds in the solar system. Moons of Jupiter *, number of moons as of now. Jupiter has at least 95 confirmed moons, and more may still be discovered. These moons range in size from giant worlds larger than Mercury to tiny asteroid-like bodies, just a few kilometers across. The 4 largest moons are called the Galilean moons, Io, Europa, Ganymede, Callisto. The smaller moons are mostly irregular, captured asteroids or icy bodies. The Galilean moons, the Big Four, discovered in 1610 by Galileo Galilei with a telescope. These moons changed our understanding of the universe. For the first time, humans saw celestial bodies orbiting something other than Earth, proving not everything revolves around us. Let's explore them one by one. Io. Unique feature. Most volcanically active body in the solar system. Surface covered with hundreds of active volcanoes, lava lakes, and sulfur deposits, giving it a colorful yellow-red appearance. Cause of activity: gravitational pull from Jupiter and neighboring moons Europa. Ganymede creates powerful tidal heating inside Io, driving volcanic eruptions. Atmosphere: thin, mostly sulfur dioxide. Importance: Io shows us how tidal forces can heat and reshape a moon's interior, even without much sunlight. Europa. Unique feature: a smooth, icy world with a possible subsurface ocean. Surface crisscrossed by cracks and ridges of ice, but very few craters, meaning the surface is geologically young. Ocean: beneath its ice shell, estimated 15 to 25 kilometers thick, may lie a global salty ocean, kept liquid by tidal heating. Life potential: Europa is one of the best places in the solar system to search for alien life, since its ocean may have the right conditions for biology. Atmosphere: very thin, containing oxygen, not breathable, but interesting. Ganymede. Unique feature: largest moon in the solar system, even bigger than Mercury. Size: about 5,268 kilometers in diameter. Surface: a mix of dark, older terrain with many craters, and lighter, younger terrain with ridges and grooves caused by tectonic processes. Magnetic field: the only moon in the solar system with its own magnetic field. Ocean: evidence suggests a deep underground ocean may exist beneath its icy crust. Importance: a world in its own right, with geology and magnetic activity comparable to planets. Callisto. Neat feature: one of the most heavily cratered objects in the solar system. Surface: ancient and covered with impact scars, showing little geological activity for billions of years. Interior: thought to have a mixture of rock and ice, possibly with a subsurface ocean. Radiation: unlike Europa and Io, Callisto lies farther from Jupiter's radiation belts, making it a safer candidate for future human bases. Importance: a fossil world that preserves the early history of the solar system. Smaller moons apart from the Galilean giants. Jupiter has dozens of smaller moons. They can be grouped as follows: inner moons, Metis, Adrastea, Amalthea, Thebe, tiny moons close to Jupiter, helping feed dust into its faint ring system. Irregular moons: many outer moons are captured asteroids or icy objects. They have odd, tilted, and sometimes retrograde orbits moving opposite to Jupiter's rotation. These smaller moons may be leftovers from the early solar system or captured objects that wandered too close to Jupiter's gravity. Interactions between moons and Jupiter. The moons and Jupiter are linked in fascinating ways. Io's volcanoes release gas, that contributes to Jupiter's radiation environment and auroras. Europa's ocean is influenced by Jupiter's gravity and magnetic field. Ganymede and Callisto affect Jupiter's magnetosphere in unique ways. The gravitational resonance between Io, Europa, and Ganymede, called the Laplace resonance, keeps their orbits stable and generates tidal heating. Scientific importance: natural laboratories. These moons show a wide range of geological activity, from volcanic to icy ocean worlds, clues to life beyond Earth, especially Europa and possibly Ganymede, which may host subsurface oceans suitable for life. History of the solar system. Callisto preserves an ancient record of impacts, while the smaller moons reveal capture events. Exploration of Jupiter's moon's past missions. Galileo spacecraft, 1995 to 2003, studied the Galilean moons in detail. Voyager 1 and 2 1979 gave us the first close-up views. Juno since 2016 studies Jupiter, but also captures images of moons. Future, Europa Clipper NASA, 2020s, will study Europa's ice shell and ocean juice. ESA, 2020s, Jupiter Icy Moons Explorer, focusing on Ganymede, Europa, and Callisto. Jupiter's moons form a mini-solar system with incredible diversity. Fiery Io, oceanic Europa, giant Ganymede, ancient Callisto, and dozens of smaller companions. They are not just satellites, they are worlds with their own secrets, histories, and possibilities for life. Exploration of Jupiter. Ancient observations. Jupiter has been known since antiquity. Babylonians, 7th–8th century BCE, recorded Jupiter's movements and associated it with their god Marduk. Greeks and Romans named it after their king of gods, Zeus, in Greek. Jupiter, in Roman mythology, Galileo Galilei, 1610, using one of the first telescopes. Galileo discovered Jupiter's four largest moons: Io, Europa, Ganymede, Callisto. This was groundbreaking evidence that not everything revolves around Earth, challenging the geocentric view of the universe. Early space missions. Jupiter became a key target once humans began exploring space with spacecraft. Pioneer 10, 1973, first spacecraft to fly past Jupiter, gave the first close-up images of the planet, discovered Jupiter's strong magnetic field and intense radiation belts. Pioneer 11, 1974, passed closer to Jupiter, confirming dangerous radiation levels, observed the Great Red Spot in polar regions in detail. Voyager era 1979, the Voyager 1 and 2 spacecraft gave humanity a spectacular new view of Jupiter, discovered active volcanoes on Io, the first ever seen beyond Earth, found complex structures in Jupiter's faint rings, revealed Europa's cracked, icy surface, hinting at a subsurface ocean, showed Ganymede and Callisto's varied surfaces, captured breathtaking images of Jupiter's storms and atmosphere. These discoveries made Jupiter and its moons some of the most fascinating targets for future exploration. Galileo Orbiter, 1995 to 2003. The Galileo mission was the first to orbit Jupiter, studied the atmosphere, storms, and magnetic field for years, sent a probe directly into Jupiter's atmosphere, which measured pressure, temperature, and composition before being destroyed by heat and pressure. Made detailed studies of the Galilean moons, found evidence of an ocean beneath Europa's ice, observed Io's volcanic eruptions, mapped Ganymede's surface and magnetic field, studied Callisto's heavily cratered terrain, revealed that Jupiter's radiation belts are even harsher than expected. The Galileo spacecraft revolutionized our understanding of Jupiter. New Millennium missions. Cassini, 2000 flyby on its way to Saturn. Cassini flew past Jupiter and took high-resolution images of the atmosphere and auroras. New Horizons 2007 flyby used Jupiter's gravity to slingshot toward Pluto. Studied Jupiter's weather and volcanic activity on Io Juno mission 2016, present currently orbiting Jupiter. Juno is one of NASA's flagship missions, enters a highly elliptical orbit to avoid intense radiation. Main objectives: study Jupiter's atmosphere and weather patterns, investigate the magnetic field and magnetosphere, measure gravity to determine whether Jupiter has a solid core. Discoveries so far: Jupiter's storms and belts are deeper than previously thought. The Great Red Spot extends far into the atmosphere. Strange polygonal storms at the poles, with multiple cyclones arranged in patterns. More detailed maps of Jupiter's auroras. Juno continues to send back stunning images and scientific data. Future missions: Europa Clipper. NASA launch planned mid-2020s will orbit Jupiter and make multiple flybys of Europa. Main goal: study Europa's ice shell and look for signs of its hidden ocean and habitability. JUICE, Jupiter Icy Moons Explorer. ESA, launch 2023, arrival 2031. European Space Agency mission will study Ganymede, Europa, and Callisto, first spacecraft to orbit a moon other than Earth's. Ganymede, potential future concepts: a lander on Europa to drill through ice and search for life, orbiters or probes for Io and Ganymede, more advanced atmospheric probes for Jupiter itself. Why exploration of Jupiter matters: planetary science. Jupiter holds clues about how giant planets form, both in our solar system and around other stars. Astrobiology. Europa and Ganymede may have oceans that could support life. Radiation studies. Understanding Jupiter's radiation environment helps prepare for deep space exploration. Solar system protection. Studying Jupiter's gravitational role shows how it influences comets and asteroids, possibly shielding Earth from impacts. Exploration of Jupiter has moved from ancient stargazing to modern spacecraft missions. Each mission: Pioneer, Voyager, Galileo, Juno unveiled new mysteries, while future missions like Europa, Clipper, and JUICE will dive deeper into the secrets of Jupiter's moons. Together, they make Jupiter not just a planet, but a gateway to understanding the origins of our solar system and the possibility of life beyond Earth. Asterisk. Importance of Jupiter in the solar system. Asterisk. The largest planet. The solar system's giant Jupiter is so massive, 318 Earth masses, that it dominates the solar system after the Sun. Its gravity strongly influences nearby planets, asteroids, and comets. Because of this, Jupiter is sometimes called the vacuum cleaner or guardian of the solar system, shielding Earth from space hazards. Jupiter's powerful gravity captures or deflects comets and asteroids. Without Jupiter, Earth might have been bombarded by far more impacts, possibly preventing life from developing. Example: in 1994, comet Shoemaker-Levy 9 slammed into Jupiter. The planet absorbed the impact, showing how it protects the inner planets from similar disasters. Influence on the asteroid belt. Between Mars and Jupiter lies the asteroid belt. Jupiter's immense gravity prevented these rocky bodies from forming into another planet. Instead, they remained scattered as asteroids and dwarf planets, giving scientists a preserved record of early solar system material. Shaping orbits and planetary motion. Jupiter's gravity affects the orbits of many solar system bodies. Some comets are pushed into the inner solar system where we can see them. Other objects are trapped in stable orbits called Trojan asteroids, which share Jupiter's orbit around the Sun. This gravitational control helps stabilize the solar system over billions of years. A key to understanding planet formation. Jupiter likely formed early in the solar system's history, becoming the first giant planet. Its massive presence influenced where and how the other planets formed. Many astronomers believe Jupiter's migration in the early solar system helped shape the orbits of Mars, Saturn, and the outer planets. Studying Jupiter helps us understand how gas giants and exoplanetary systems form around other stars. a natural laboratory for science. Jupiter's powerful magnetic field, storms, auroras, and radiation belts give scientists a natural space laboratory to study extreme environments. By observing Jupiter, we test theories about weather, magnetism, and planetary dynamics that also apply to exoplanets. Its moons as potential homes for life. Jupiter's moons, especially Europa, Ganymede, and Callisto, are prime candidates in the search for life beyond Earth. These worlds may contain oceans beneath their icy shells, offering environments where microbial life could exist. Thus, Jupiter indirectly holds the key to answering one of humanity's biggest questions: are we alone? Cultural and mythological importance for ancient civilizations. Jupiter was a bright, wandering star in the night sky. Its significance in myth: Zeus, Jupiter, king of gods, reflects its dominant position in the heavens. Today, it remains a symbol of power, size, and cosmic influence. Jupiter is more than a planet. It is the gravitational guardian, cosmic architect, and scientific key to understanding our solar system. Without Jupiter, Earth and life itself might not exist in the same way. Studying it helps us see how planetary systems work, both here and in distant star systems. Jupiter in mythology and culture. The name Jupiter the planet is named after Jupiter, the king of the gods, in Roman mythology. In Greek mythology, this same god is known as Zeus, ruler of Mount Olympus, and god of the sky and thunder. This naming reflects the planet's brightness and dominance in the night sky. Just as Jupiter, Zeus, was dominant in mythology, Babylonian and Mesopotamian cultures. Ancient Babylonians associated Jupiter with Marduk, their supreme god of creation and order. They carefully tracked Jupiter's movements and linked them with omens, believing the planet guided the fate of kings and empires. Chinese and Eastern traditions. In ancient Chinese astronomy, Jupiter was called the year star Suising because it takes about 12 years to orbit the sun. This 12-year cycle became the basis of the Chinese zodiac, with each year linked to one of 12 animals: rat, ox, tiger, etc. Closing parenthesis. Jupiter was also associated with the element wood and was seen as a sign of growth and prosperity. Hindu mythology. Hindu tradition. Jupiter is known as Brihaspati, or Guru, the teacher of the gods and a symbol of wisdom. Brihaspati is considered a planet of knowledge, spirituality, and guidance. In Vedic astrology, Jupiter is believed to bring fortune, learning, and blessings. Mayan and Mesoamerican beliefs. The Maya civilization carefully observed Jupiter's path across the sky. They included Jupiter in their complex calendar and associated it with certain gods of war and rulership. Its position was believed to influence agricultural cycles and royal authority. Western astronomy and philosophy. After Galileo discovered Jupiter's 4 largest moons in 1610, the planet became central to debates about the universe. It challenged the geocentric model, Earth at the center, and supported heliocentrism, Sun at the center. This discovery had a huge cultural impact, changing humanity's view of our place in the cosmos. Modern cultural impact. Jupiter remains a symbol of power, greatness, and mystery in modern culture. In literature, films, and music, Jupiter often represents cosmic grandeur or divine authority. Gustav Holst's orchestral suite, The Planets, includes a movement called Jupiter, the bringer of jollity, reflecting its majestic presence in science fiction. Jupiter and its moons are frequent settings for future colonization, exploration, or alien life stories. For example, 2001, A Space Odyssey, and The Expanse. Astrological significance. In Western astrology, Jupiter is considered the planet of expansion, wisdom, good fortune, and growth. It is said to influence philosophy, religion, travel, and higher knowledge. People look to Jupiter's position in their birth charts for insights into luck and spiritual development. From Babylonian gods to Chinese zodiac cycles, from Galileo's telescope to modern science fiction, Jupiter has always represented greatness, wisdom, and cosmic power. Its size and brilliance made it a natural symbol of kingship, divinity, and destiny, shaping both ancient beliefs and modern culture. Asterisk fun and interesting facts about Jupiter. Asterisk the biggest of them, all Jupiter, is so large that it could fit 1,300 Earths inside it. Despite this, it spins faster than any other planet, making a day less than 10 hours long. A failed star Jupiter's composition, mostly hydrogen and helium, is almost the same as the Sun's. If it had been about 80 times more massive, nuclear fusion would have started, and Jupiter would have become a star instead of a planet. The Great Red Spot. The Great Red Spot is a storm bigger than Earth that has lasted for at least 350 years. If Earth were inside the storm, it would be swallowed whole with room to spare. Radiates more heat than it gets. Jupiter emits about twice as much energy as it receives from the Sun. This is leftover heat from its formation and from slow contraction under its own gravity. Powerful magnetosphere. Jupiter's magnetic field is the strongest of all planets, about 20,000 times stronger than Earth's. Its magnetosphere is so huge that if we could see it from Earth, it would look larger than the moon in the sky. Auroras that outshine Earth's. Jupiter has dazzling auroras at its poles, far more powerful than Earth's northern lights. These auroras are fueled not only by the solar wind, but also by volcanic gases from its moon, Io, largest moon in the solar system. Ganymede, one of Jupiter's moons, is larger than Mercury. It's the only moon known to have its own magnetic field. Fast spin makes it squash-shaped Becos. Jupiter rotates so quickly, it is wider at the equator than from pole to pole. This makes it an oblate spheroid, not a perfect sphere. Asterisk, enormous gravity. Jupiter's gravity is more than 2.5 times stronger than Earth's. If you could stand on a surface there, which you can't, because it's a gas giant, you would weigh nearly 3 times more than you do on Earth. A mini solar system with at least 95 moons and faint rings. Jupiter is almost like a solar system within a solar system. Its moon system is so diverse that scientists consider each of the 4 Galilean moons to be a world of its own, discovered in a day. Still a mystery. Galileo discovered Jupiter's biggest moons more than 400 years ago. But even today, missions like Juno are still uncovering new surprises about its storms, core, and magnetism. Jupiter is a planet of extremes. The fastest spinner, the biggest planet, the most powerful magnetosphere, and home to the largest moon. It's not just a giant ball of gas. It's a dynamic, stormy, and fascinating world that still holds many secrets waiting to be discovered. Asterisk, Jupiter is not just the largest planet in our solar system. It is a cosmic guardian, a giant laboratory, and a source of endless wonder. From its swirling storms and mighty magnetic field, to its family of moons that may hide oceans and life, Jupiter stands as a reminder of how mysterious and beautiful the universe can be. For thousands of years, it has inspired myths, guided calendars, and fascinated sculptures. Today, with modern spacecraft orbiting its clouds and future missions heading toward its icy moons, Jupiter continues to challenge our knowledge and expand our imagination. As we study this mighty world, we are not only learning about Jupiter itself, we are also unlocking the story of our solar system, the origins of planets, and perhaps even the conditions for life beyond Earth. Jupiter is more than a planet. It is a gateway to understanding the cosmos, and so, the king of planets remains above us, shining brightly in the night sky, a symbol of power, mystery, and the boundless quest for discovery that drives humanity ever forward into the stars.